Is the mic working? Right. Oops, sorry, I've got the timers going. Let's get rid of the timers. Right, this is question 1. It's actually a lot harder than a 60-minute question, so I'm going to give you 5 minutes to have a go at this one. This is a much tougher sheet. Good luck with it. Here we go, 5 minutes. 1 minute to go. With the timer. We've got a curve is given by equation y equals sec x, and the line L1 is the line which lies tangent to the curve where x equals pi by 3. Find the equation of L1 in exact form. So the first thing we want to do is we want to find the gradient of this line at this point. So let's find dy by dx. So we know that y equals sec x. I always think it's good practice to write out the equation you're given in the question, because if you get copying errors, they will follow through your marks, follow through your mistake and give you the marks. So sec x goes to sec x tan x when you differentiate it. And we know that at x equals pi by 3. So we've got dy by dx will equal sec of pi by 3 times tan of pi by 3. Now sec is 1 over cos. Cos of pi by 3 equals a half. 1 over half equals 2. Tan of pi by 3 is equal to root 3. So we've got 2 times root 3 for that. And if x equals a third pi, then we know that sec equals 1 over cos of a third pi, which we just showed as equal to 2 when we worked that out. So therefore, the y value would be equal to 2. So we've got a y value, we've got an x value, and we've got the gradient. So we can use y equals, y minus y1 equals mx minus x1, where x1, y1 is a point on the line, pi by 3, 2, and m is the gradient. So y minus 2 will equal 2 root 3 x minus pi by 3. And that gives us the equation of L1 in exact form. We could try multiplying out. I don't think there's anything that's going to make this any nicer than it is at the moment. It's not a particularly nice equation, and it's not going to get much better when we multiply it out. Now, we want to show the line meets the curve a second time when x equals 4.8, correct to 1 decimal place. So what we've got is we know that y equals sec x, and we want to know when it crosses this curve. So if y equals sec x, we can replace this y with sec x. So let's go ahead and do that. So sec x is equal to y minus 2 equals 2 root 3 x minus pi over 3. And we want to show that it meets the curve a second time when x equals 4.8. Now what I think is a good thing to do at this stage is to write this all on one side. Sec x minus 2 root 3 x minus pi by 3 equals 0. Okay, now if we let f of x equal that, equals sec x minus 2 root 3 x minus pi by 3. Okay, I don't need that last little dash there. Let's get rid of that. Then, if we know that we want to show that it meets the curve a second time when x is 4.8, correct to 1 decimal place, if we put the value 4.75 into this and the value 4.85 into this, and you have a sign change, and you know that it's been 0 in between those two, and therefore it must have a second solution in that range of values. Therefore, it's 4.8 to 1 decimal place. So let's do that. So let's do f of 4.75. I'm not going to show you how to put it into your calculator. put that into the calculator, and you get minus 11.67, I do believe. And if you do f of 4.85, put that into your calculator, you get 7.88. So as we have a sign change, there's a root between 4.75 and 4.85. So there, and it's a continuous function, so therefore we have a solution. It cuts a second time. When x is equal to 4.8 to 1 decimal place. Okay, and I know it's correct to 1 decimal place because I took the boundaries of this as 4.75 and 4.85, put them in, negative and a positive, and therefore this must give us our answer. Right, our next question. All these derivatives to do, some of them getting quite tricky towards the end. I'll give you another 5 minutes to have a go at all of these. 1 minute to go. Okay, that caused some fun for the set I got here. So let's go through it. So 2a, I think this was quite straightforward. Product rule. We want to find dy by dx for that. We differentiate the x, so we get 1 times tan x. Plus differentiate the tan x, that goes to sec squared x, and we times that by x. This is just product rule. So we differentiate one and then times it by the other, and differentiate the other thing and times it by the first thing we started with. So that is A. B. Again, we've got another product rule with a little bit of chain rule going on. And it's so easy you probably don't even think about it. So x squared differentiated is 2x times by cot x, or cot 5x should I say. And then we're going to differentiate cot, and that gives us minus cosec squared. But we've got a 5 coming out from the chain rule part of it. So we're going to get a 5 cosec squared x, and then we're going to times that by x squared. So we're going to get minus 5x squared cosec squared 5x. Let's just go through that again. So the 5x, that differentiates to give us 5. So we're going to get, that's where that 5 comes from. Cot goes to minus cosec squared x, and then we're going to times by the x squared. So part C. Now we've got implicit differentiation here. Well, the 1's quite straightforward. We just differentiate to get 0. X squared, nice and easy. Differentiate to respect to x, we get 2x. Plus, now the tricky bit. We've got the chain rule here, but there's a product rule inside, and an implicit differentiation in the product rule. So if we just differentiate the x, y, differentiate the x, you get 1 times y. Plus, differentiate the y, we get dy by dx times x. So that's the inside bit of our chain rule. So we're going to write y plus x dy by dx. And then we're going to times that by the derivative of tan, which gives us sec squared. And we leave the inside function in there. So we get sec squared x y. We could probably multiply this out, but I can't see that it's going to really benefit us. Although it does say find dy by dx, so I better get on. Actually, I do need to do that. So let's just do that. So I get 2x plus y sec squared xy plus x dy by dx times sec squared y. So I've got x sec squared xy times dy by dx. And if I rearrange this, if I get dy by dx on its own, I'll get minus 2x minus y sec squared xy. And I'm going to divide all of it by x sec squared x y. Right, I'm just going to rub this little bit of working out here to give myself some space to do part C and D. I might struggle to get this all in here. So, oh no, just on C, so part D. So part D, we've got a nice big chain rule problem to do. So we've got a chain rule of a chain rule of another chain rule of a chain rule going on there. So that's going to be entertaining. Let's see if we can do this all in our heads. So the way I'm going to look at it first is I want to differentiate the inside bit here. Okay, because I'm going to have something to the power of 5, so that's obviously going to be 5 times something to the 4. But I want to differentiate this something. Now cot 4x. Now cot goes to minus cosec squared, and I'm going to times that by 4. So minus 4 cosec squared 4x. And then just put that equals in. then I want to differentiate the tan squared 2x. Now, we can think of tan squared as being tan of 2x all squared. So I'm going to have a 2 coming down. And then I'm going to have the tan 2x. Well, tan goes to sec squared, so I'm going to have that sec squared. And I've got the 2 coming out, so I've got another times by 2. So I'm going to replace, let's just rub that out and just put another times by 2 in. Useful having a whiteboard like this. So times 2, what I said, tan 2x, I need to sec squared coming out of that from the 2x. And then I've got tan 2x inside the function, and we take 1 off the power to leave me just the tan 2x. So I've now differentiated the inside part of this function. So I can just put brackets around that. And then I've got to times it by this bit to the 5 differentiators. So I'm going to need it times by 5. All the inside bit, cot 4x minus tan squared 2x all to the power of 4. And that's a bit of a mess. I don't think I really want to try and simplify that. I'm just going to leave that as I can't really, and I can probably bring the 5 and bring these 4 bits. I've got a factor of 4. So actually let's just tidy up a little bit. Let's bring the minus 4 and the 5, so that's going to give me minus 20 cosec squared 4x minus sec squared 2x tan 2x all times by cot of 4x minus tan squared 2x to the 4. I could probably tidy up getting this minus if I change these two around, make that a plus and make that a minus, but we don't really need to do that for the purpose of this video. So let's move on to the next question. And we've got a Newton's rule of cooling problem here. I think, just give me a second. I'll just grab the Newton's rule of cooling for you. Just give me a second. I'm just going to screenshot that just to remind you. There you go. There's Newton's law of cooling. If you need reminding, T equals T temperature environment plus temperature time naught minus temperature environment e to the minus RT. So use that to help you try and do this question. 1 minute to go. Right, hopefully that was enough time for you to have a good go at that question. So, explain briefly why Newton's law of cooling might apply to a body temperature of someone who's fallen in the sea, but not someone who falls in the bathtub. I think it would be the case of the volume of water being the main factor. So the volume of water in the sea is much bigger, is much greater than in the bath. So therefore that will have a greater effect on your body temperature than the volume of the water in the bath. And also the volume of water in the bath will also be cooling from the air around it as well, whereas the volume of water in the sea is not so much affected by the air around it as the bath will be. Anyway, back to here, we've got normal body temperature as 36.9. Hypothermia is when your body loses heat faster than it can produce and sets in at 35 degrees C. So he falls in the icy waters of the Atlantic Ocean. The first minute, the water temperature 2 degrees C, his temperature drops from 36.9 to 36.5. So how long does Rose have to rescue him? So what we need, first of all, we need to find our constant here, R, by putting in the values we know. So the temperature at time t is 36.5. The temperature in the environment is equal to 2. Plus the temperature at time t0 minus the temperature in the environment. So the temperature at t0 is 36.9 minus 2 times e to the minus rt, and t is equal to 60 seconds. Now, if you're working in minutes, then obviously you're going to get a different r, and you have to be consistent in the rest of the question. So you may get a different answer if you used 1 here rather than 60. So we've got 36.5 equals 2 plus 34.9 e to the minus 60r. Take away 2 divided by 34. So we get 34.5 over 34.9 is equal to e to the minus 60r. So get rid of the e by doing natural log of both sides. So get natural log of 34.5 over 34.9 is equal to minus 60r. So therefore r will equal minus 1 over 60 times by the natural log of 34.5 over 34.9. And that comes out to be 0.000192. So we've got to try and save this person before their body temperature drops down to 35. So we've got the problem where we've got 35 is the temperature we're concerned with, equals 2 plus 36.9 minus 2 e to the minus all that 0.000192 t. So take the 32 from the 2 from the 35 gives us 33. Simplify that to 34.9 e to all that stuff. So you get 33 over 34.9 equals e to all that stuff. So all that stuff will be equal to natural log 33 over 34.9 will equal, what was it, minus 0.00192 t. So divide this by that and we'll get t. So t is equal to natural log of 33 over 34.9 divided by minus 0.000192. And you should be keeping all the figures on your calculator here to get a more accurate answer. And if you've done it correctly, you should get t is about 291.6 seconds for significant figures. So to the nearest second, it'd be 292 seconds. Right, next question. This should be a little bit easier if you can remember how to do your differentiation by first principles. So I'm going to give you just 3 minutes to do this question. Right, let's have a look at this question. So, as long as you can expand this, it should be quite straightforward. So if we can do f of x plus h, that's going to be equal to 5 times x plus h all cubed minus 2 times x plus h. And we can use the binomial theorem to do this. So this bit expands to x cubed plus 3x squared h plus 3xh squared plus h cubed minus, and we've got 2x plus 2h, and I can multiply it all by 5 to get 5x cubed plus 15x squared h plus 15x h squared plus 5h cubed minus 2x plus 2h. And then we want to develop an expression for this. So f of x plus h minus f of x is going to be all of this. So write that all out again. It's a bit of a pain. 15xh squared plus 5h cubed minus 2x plus 2h. I'm going to take away f of x, which is 5x cubed, and plus 2x, because minus and minus will give me a plus. And then I can cancel some terms out. So that one will cancel out with that one, and this one will cancel out with this one. So therefore, f dash of x is equal to all of this, 15x squared h, plus 15x h squared plus 5h cubed, plus 2h all over h. So we can do a bit of cancelling here as well. So let's just cancel that with that, that with that. That will go to a 2, and that will go to a 1. And so I'm left, once I've cancelled down, 15x squared plus 15x h plus 5h squared plus 2. Now, as h tends to 0, then f dashed of x will tend to, well, that bit's going to go and that bit's going to go. 15x squared plus 2, and I've made a mistake. Let's just go back and have a look. And it's here, minus 2x plus h. I should have had a minus here, and here, and here, and here, and here. So all those should have a minus in front of them. So there, 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 and there. So we get f dash of x goes to 15x squared minus 2. Always very good to check your answer against the question what's going on. And especially as you know how to differentiate this normally, you should find this really easy without doing it by first principles. When you've done the first principles, check that your answer matches up with the question. Next one. Okay, nice straightforward binomial expansion. I'm going to see if you can get this off in 60 seconds. Off you go. Right, here we go. So, 4 minus 2x to the power of 6. Using the binomial theorems, you get 4 to the 6 plus 6c1, 4 to the 5 times by minus 2x to the 1, plus 6c2, 4 to the 4 times minus 2x all squared. And it says first 3 terms. Well, there's a term, there's a term, there's a term. So that's 3 terms. So all we've got to do is shove that into the calculator. So you get 4,096 minus 6c1 times 4 to the 5 times minus 2. So they get the minus there. 12286x. And then we're going to get 6c2 times 4 to that, and then minus 2 squared. So it's going to be a plus. Common mistake is to forget to square the minus 2 here. So we get 15,360x squared. And there's other terms in this expression, but we don't need to go any further because it just says write down the first 3 terms in ascending powers of x. Right, another tricky-ish question. I'm going to give you 5 minutes to have a go at this, and let the class knock it off a lot quicker. Here you go. Sorry, that should be an 8 there. I can't read my own writing and my own answers I've already done. Here you go. 1 minute to go. Right, here we go. So my set here are getting some entertaining answers on this question. So let's go through it. Write down the value of my investment after interest has been awarded at the end of the first year. So you've got £2,000. The interest is 2%. So you're going to times by 1.02. So you do 2,000 times by 1.02 gives you the amount at the end of the first year, which is £2,040. Now for part B, I always think it's a good idea to get a feel for what's going on in this question. So that's the end of your first year, is 2,000 times 1.02. Then if you get to the end of the second year, you're going to get that amount of money times by 1.02 again. But you're going to have another 2,000 deposited at the beginning of that year, and that 2,000 will get an interest of 2% on it. And then if we do a third year, this will get times by another 1.02, this get times by another 1.02, and then we add in a deposit of 2,000, and that's also will earn interest of 1.02. So the lowest term in our sequence is always this 2040. So that is our A term, our first term. And to get from there to the next term, we can see we times by 1.02. So the nth term is actually going to be equal to 2040 times by 1.02 to the n minus 1. Now we want to know the amount of money in the account at the end of the 10th year, which is the sum of this geometric. And the sum of a geometric is equal to A times 1 minus r to the n over 1 minus r. So after 10 years, we will have 2040 times by 1 minus r, which is 1.02, to the power of 10, because of 10 years. And then we're going to divide by 1 minus 1.02. Shove that all into your calculator, and you should get 22,337.43 pence. Okay, so we want to find precisely when the balancing account will first pass 50,000. Let's see how much space we've got. We've got that much space. Right, I'm going to try and get that in. So I've got 2040, open brackets, 1 minus 1.02 to the n, we don't know what year, over 1 minus 1.02. And we want to know when that will be greater than or equal to 50,000. So if I times that by the difference between this, which is minus 0.02, then divide by 2040, we will get 1 minus 1.02 to the n will be less than or equal to minus 0.490196 and so on, because the sign is flipped because we times by a negative number here. So take 1 off both of those, so I get minus 1.02 to the n is less than or equal to minus, it's going to have a 1 there, 1.49 and all the rest. Change sign of both of them, so let's just rub that out, change the sign there, change the sign there, and then we've got to flip this so that it goes the other way. So change sign of both sides. And now we can take logs of both sides. So we've got log of 1.02 to the n is greater than or equal to log of 1.4. And then we've got bring the n outside using that little bit of the formula in the logarithms rules. We get n log 1.02 is greater than or equal to log of 1.4 and all the rest. So n will be greater than or equal to log of 1.02 4 over log of 1.02, and so therefore we get that's greater than or equal to 20.14. So therefore our n should be 21. Now I always reckon it's worth checking in our formula with both 20 and 21 just to make sure you haven't made a sign mistake, because do you know what the sign of log of 1.04 and 1.02, hopefully you know they're both positive, we should get that, is equal to 21. And if you put that, I always recommend that in the exam or any test, shove in 20 and shove in 21 back into your original problem just to make sure that you chose the right value, okay, either side, and it's not the other one that you didn't get, okay. So that's how you do that question. Let's move on to the next one. And this looks quite simple, but actually is a really tricky geometric problem. I'll just move that so as you can see that without the logo in the way. Sorry, I'm moving the wrong thing. Let's move that. I need the question. There we go. So you can see the whole of this question. In the diagram below, a circle is inscribed, that's inside, with a sector of radius 5 centimeters and central angle 40 degrees. Determine the shaded area. I'm going to give you about 5 minutes, believe it or not, to try and work your way through this problem. I'm just going to give a hint to this question by drawing a few lines on the diagram. 1 minute to go. Right, okay, so this is a tricky question. The key thing to do getting this question is actually spotting what this red length is. You can find the area of the sector very easy. The area of the sector, all right, we do need to work out, is going to be 25 pi times by the ratio of the angle. And if we did that in GCSE, you do it that way. Normally you get these in radians questions, but on this question it comes out like this. So we get 25 pi over 9 when you work that out. Now we know that this is going to be 5 minus r. That distance is r. That whole distance is 5. So this distance is 5 minus r. This distance is r. We have a right angle, that's 20. So sine of 20 is equal to r over 5 minus r. So we can now get an expression for r. We times by 5 minus r. So we get sine 20 times 5 minus r equals r. Multiply that out, you get 5 sine 20 minus r times sine 20 equals r. Get all the r's on the same side. So 5 sine 20 is equal to r plus r sine 20. So 5 sine of 20 will equal r, factorise 1 plus sine 20. So the radius will equal 5 of sine 20 all over 1 plus sine of 20. So therefore for the circle, okay, we worked out the radius, the circle will equal pi r squared, and that will equal pi times 5 sine of 20 all over 1 plus sine of 20 all squared. And if you do that, we get 5.10 and a load of other stuff. So the area we want will equal 25 pi over 9 minus 5.101 and all the rest. And that comes out to be 3.6323 SF. I've just asked this question, why is this line here 5 minus r? What he has not spotted is that this side here is the radius, 5. This is also going to be the same length, 5. This is also the same length, 5. And the radius of my circle is r to here. So take that length off the yellow length, and I'm left with 5 minus r. Anyway, that's the end of today's stream. Hopefully we'll stream again tomorrow, and it will not be quite as arduous as this one. So see you then.